Hello all, welcome to Cocowatt Media. Today we are diving deep into the world of AURIX GPIO. In our previous video, we have covered general introduction to the GPIOs, what are the different types of modes, what is pull up, pull down and other parameters. Today we are focusing on AURIX 275 microcontrollers, general purpose input and output functionality. Whether you are a beginner or experienced, this session will be very helpful to you to increase your knowledge and master in GPIO configuration of AURIX microcontroller. So here what we are going to cover in today's session. So first we will dive deeper into the AURIX 275 GPIO architecture, building on our previous introduction to modes like push-pull and open rain, and we are going to cover what and all ports are available, what and all alternative modes are available in the AURIX microcontroller. Then we will jump into our first demo, configuring a GPIO to blink an LED, perfect for understanding the output in actions. We will then go code walkthrough with how to initialize pins, set modes and control output programmatically. Next, we will level up by adding a button input. You will learn how to read digital signal and use it to control LED. It is ideal for real-world applications like user interfaces. Finally, we will break down the code for button and LED interaction, covering input configurations, pull-up resistors and real-time state monitoring. If you are new to AURIX or wanted to deepen your understanding in AURIX, don't forget to explore our Master in AURIX microcontroller playlist. If you find this content is helpful, please like, share and subscribe to Cocowatt Media. The AURIX 27X microcontrollers is widely used in automotive and industrial applications due to its high performance computing and versatile connectivity feature. One of its critical component is the GPIO, which enables communication between the microcontroller and the external devices like LEDs, sensors, switches and more. On your screen you can see the TC27X microcontroller pinout showcasing the various ports and their corresponding pins. You will also notice that AURIX microcontroller chip itself is the powerhouse behind the automotive systems. So without any further delay, let's go into the AURIX GPIO, how many ports are there and its features. The AURIX 275 comes with 17 ports and each port has varying number of pins. These pins serve as the primary interface between the microcontroller and the external devices. You can see that port 0 has 13 pins, port 1 has 5 pins and port 2 has 12 pins and the list goes on. In total, the TC275 has over 150 pins, offers exceptional flexibility to connect with a variety of external devices and peripherals. One of the most powerful features of TC275 is each port can be configured independently. This allows to tailor the microcontrollers to suit the exact need of your application. Whether you are working on the motor control or communication interface or sensor integration, the TC275 offers very good connection option. Now you might wonder, what exactly do these ports and pads do? Well, the ports and pads serve as a bridge between the internal logic of the microcontroller and the external devices. Their primary functions includes input and output signal drivers. This shapes the incoming and outgoing signals using Schmitt trigger, pull up, pull down resistors and adjustable signal rise and fall times. And also it has electrostatic discharge protection. This protects the microcontroller from the unwanted voltage spikes or electrostatic discharge during the operation. It also has level shifting. This allows the microcontroller to operate with different voltage level such as 3.3 or 5 volt, ensuring the seamless communication with different external devices. I/O control logic. This handles the register management, bus interfaces and peripheral connectivity, ensuring smooth and efficient operation. The quick note on this is the core voltage domain of a microcontroller is 1.3 volt, whereas I/O control domain can operate at 3.3 volt or 5 volt. This is precisely why level shifting becomes so important in interfacing with external components. Now let's talk about the different features that these ports offers, because this is where the things gets interesting. The ports in the AURIX 275 microcontroller act as inputs as well as outputs. When it acts as an input, the microcontroller will receive data from external sensors, buttons and other peripherals. When it acts as an output, microcontroller drives the external devices like LED, motors or displays. Here are few key features you will find on the input side, like Schmitt, which is ensuring the clean and stable signal transition with eliminating noise. Pull up and pull down resistor, they ensure known logic level when the pin is not connected. High impedance stage. This leaves the pin in an open circuit state, preventing unwanted power consumption. On the output side, you will find push-pull mode. This can drive the pin high or low, making it ideal for controlling LED or motor. Open drain mode. This only drives the signal low. Require external pull-up resistor. It will be commonly used in I2C communication. There is one more important function, alternate functions, available in the GPIOs. Most pins can support the 7 alternative output functions, making them highly versatile. I/O multiplexing is one of the standout feature of TC275. I/O multiplexing means the single pin can perform multiple functions depending on the software configuration. For example, it can act as GPIO, UART transmitter, or SPI clock. This is all controlled by port configuration register in the microcontroller. Imagine you are building an electric motor vehicle. One pin can output PWM signals to control the motor speed. Another pin can configure for a SPI communication to interface with the temperature sensor, and another pin can be used as an input for emergency braking feedback. Now that you understand I/O multiplexing, let's talk about signal routing through ports. We will discuss how input and output signals are routed through the ports, how alternate function works, what are the registers involved. First, let's talk about input signals. Input signals are the signals that come from the external devices to the microcontroller pin. These signals are controlled using the peripheral port input select registers or PDR. This allows multiple modules inside the microcontroller to read the data from the same pin. For example, suppose you connect a button to a pin. This button input can be used as general purpose input output or external interrupt controller ERU. To configure the input, you need to select the PDR register. Then there is a multiplexer routes the signal based on your configuration. So the registers involved in input routing are PDR and port input register. PDR is the peripheral port input registers that controls where the input signal is routed, and PIN, this is the input data register that stores the input value from the pin. So now we have understood that how input signal routing works in the AURIX. Let's move on to the output signals. Output signals are flow from the microcontroller to the external device such as motor driver or LED or communication lines. These signals are configured using port I/O control registers or port OMR. The AURIX 275 allows you to assign any available alternate output function to a pin. For example, let's say you want to output a PWM signal to control a motor speed. So you would set alternate 1 in POMR register, which is port I/O control register, to output PWM. Alternatively, you could set alt2 to output a SPI clock signal. So, what are the registers involved in output routing? First, port output modification register or OMR register, where you select the output function from alternate 0 to alternate 7, and output data register, that holds the value to be driven on the pin, which is P out. As we see in the output signals, we have multiple alternate functions are available in the TC275 microcontroller. There is a multiplexer controls which signal appear on the pin. For example, alternate 0 is GPIO output and alternate 1 is PWM output and alternate 2 is a SPI output and alternate 3 is a CAN bus signal. This functionality allows you to utilize the same pin for different functions based on the design you needs. You can change the function dynamically using P OMR register or output module configuration register. For example, imagine you have a motor control circuit. Initially, you are using alternate 0, which is the basic GPIO control to turn on and off the motor. Later, you decide to use alternate 1 to generate PWM signal for speed control. Simply modifying the port OMR registers will allow you to switch to the other functionality. Then there is a pad control register. This register allows you to configure pull up or pull down resistor at the output or as an input using PDISC register. This prevents the floating states, especially in input mode, and this controls the default pin when no output is driven. And there is a EM stop signal allows for quick disable of outputs in case of emergency such as motor overcurrent. Then there is a hardware enable signal which controls via hardware enable register. Let the hardware peripheral directly control the pin without software intervention. So in summary, the input signals are managed using peripheral port input select register or port PDR register. Output signals are controlled using port IO control register or port OMR register, and the alternate functions allow a single pin to perform multiple roles, and the pull devices prevent floating states and ensure clean signal readings. Emergency stop and hardware enable provides additional safety and control. This mechanism makes AURIX TC275 microcontroller highly flexible and suitable for complex automotive applications. Okay, now let's move on to the another important concept, pad types. The TC275 supports various pad types, each optimized for different types of connections. 3.3 or 5 volt switch pads. These pads can operate at either 3.3 volt or 5 volt, making them compatible with most industrial and automotive devices. LVDS pads or low voltage differential signals. These are used for high speed communication between chips such as Ethernet, camera interface, or data logging systems. ADC pads. These supports analog to digital conversions, allowing you to measure analog values like temperature, voltage, or current. So whether you are working with sensor, motors, or external modules, TC275 has the pad fits your need. And finally, let's talk about speed grades. The high speed application controlling the rise and fall times of the signal is crucial to minimize the EMI or electromagnetic interference. The TC275 offers 4 speed grades. Speed grade 1 offers the faster signal switching, ideal for high speed communication. Speed grade 4 provides slow signal rise time, reducing EMI interference in sensitive applications. If you are working on motor control or industrial applications, choosing slower speed grade will reduce noise and improve system stability. So always balance speed versus EMI based on your applications. So in this section, we will learn how to blink an LED using general purpose input output or GPIO pin in AURIX TC275 microcontroller. We will go step by step by setting up a GPIO to making a blink LED continuously. Let's get into the code walkthrough. Okay, let's open AURIX Development Studio. and I have already loaded with the LED blink program. We have already put a video on how to get started with the AURIX development board, which is AURIX TC275 Lite board. Please check out the video in the link. So after the startup, the core will come into the core 0 main function. So if you want to understand how the AURIX startup works, we have already put on a video on AURIX startup, how multiple cores have start and how the startup function work. Please check out the previous video in the link below. Let's get started with the blinky program. So I have opened the CPU main function. Here you can see LED was initialized and then LED blink was called. So to blink an LED, first we need to initialize the port which port we have to select the port. Here it was selected with port 0 pin 5, so which is the pin available in the development board. Here it was called with the set pin mode, so which is a function which is used to set the port 0 fifth pin as output mode. And then we have used we have configured it as push pull configuration. Inside set pin we can see that IOCR register was configured used to configure as output. And then after configuring the port 05 as output pin, here we have initialized it with off by using uh, I by using this port set pin high function. So inside it we can see that OMR register have called uh, to set by setting the OMR register we can set the output pin to high or low. So here we are initializing the register and then initializing the pin as well. So and then we have called the LED blink function inside the while loop 1 infinite loop. So you can see it is calling again the mm, it is calling the set pin state where the toggling will happen every 500 millisecond as we call the while loop and then wait function with the 500 millisecond time delay. So with this simple program, LED blink will work well. Okay, our blinking program is ready. Let's flash and see what's the output. Okay, I will build the program once. Before that, I will clean the project and then build the project. Okay, build also successful. Let's flash and see. Here you can see in the video stream that no LED is blinking in the development board. Let's flash. Okay, flashing successful, and see the port which we have configured is blinking perfectly. So we have completed our LED blinking program with a code walkthrough in a AURIX TC275 Lite board. Next, let's move on to the demo to switch LED program with a code walkthrough in AURIX 275 Lite board. Okay, I have already loaded a LED button program. uh, let's move on how to configure. So we know that to configure LED with the input switch, we have to first initialize GPIO, and then we have to call the logic function. Let's first get into the initializing of GPIO. So I have used the same output pin which we have used for LED blinking, and I have used one more input pin in the development board, which is port 0 7th pin, which is already connected to a button. So I have used this pin as a input. Okay, so we have to configure first the input pin as button pin as input and the LED pin as output. Okay, so we know already how to configure LED as output.
So you see that the pin mode which is set to output and general push pull have configured, and we have so a button pin is configured as input with the input pull up. So we know that why the pull up is used. So if we configure the input register as pull up, then during the floating condition the high will be set to the register. Okay, so this is how we have configured. So if you want, you can see that it is configured by a IOCR register, right? So if we configure this, then the mode of the pin will be set to input with the input pull up in internal pull up register will be enabled. Next, we should write a logic by using the input pin. Okay, so I want to get the data in the input pin. We know that to read the data from the pin, we are using IN register. So if the data from the pin is 0, then set the pin as low, and if the data in the pin is 1, then set the pin as high. So to set the pin as high, as usual, we should call OMR register to make the pin as high and low. So let's flash and see what's happening. So our program is ready, and we have called the control LED function in the while loop and the init GPIO function in the main. Let's build this project. I have already cleaned, so I will build this project. Okay, so it is ready and it is successful as well. Let's flash it. Yeah, flashing also successful. Let's check the output. Okay, when pressing the button, I can see the LED start glowing, and when I leave the button, the LED set to low.
Thank you for watching this video on GPIO in the AURIX TC275 microcontroller. We hope you enjoyed demo on LED blinking and switch LED. If you found this video helpful, please hit like, share and subscribe to Cocowatt Media for more practical embedded system tutorial. Stay tuned for more exciting content. See you in the next video.